In our quest to find whether an infinite series converges or diverges, we have a new test called the direct comparison test. At the end of this lesson, you'll be able to determine whether an infinite series converges or diverges using the direct comparison test. And the direct comparison test is pretty much what it's called, talking about comparison. We are going to take the series that they give us in the problem and we're going to compare it to another series that we get to pick. So we're going to try to pick a series that's easier for us to actually find the convergence or divergence of, and then we're going to compare it with the one that we already have. And what's going to happen if the one that we started with is less than the one that I pick, and the one that I pick converges, then the original series would converge as well. And then if I pick a comparison series that's in the original one is bigger than the one that I pick, and the one that I pick happens to diverge, then the one that we started with will also diverge. So the basic trick in this one is finding the one to compare it to. We want it to be a little simpler, and it's just going to take a little bit of practice to do this. So here we go. Let's dive right in and see how we do. All right, first thing that I'd like to do is actually get rid of this problem. So we're going to start anew. The new problem, I do not want that one at all. The new one we are going to do is n equals 1 to infinity. I'm going to try to start out a little bit simpler, hopefully. Okay. All right, so this is the one we would like to decide whether it converges or diverges using the direct comparison test. I will tell you, if we use the nth term test right now, we would be all set and we could find whether it converges or diverges. But I would like to practice using the direct comparison test on a little bit easier function. All right, so that's our a sub n. All right, we're going to pick a different function, and I'm just going to call it b sub n, so it's a different one. I know in the previous slide I used c and d, but we don't know whether it converges or diverges yet, so I'm just going to call it b. So if I have b sub n is equal to, pick 1 over n plus 1, because notice it's very similar to this, it's just a little bit simpler because instead of the n, I just put a 1. And if you can think about this one, when I'm doing this one, this function a sub n is going to be bigger than b sub n. So because obviously if you started plugging in numbers, the top on this one is always going to be bigger than the top on this one, so it's going to be a bigger, this is going to be a bigger sequence. The terms in the sequence will be bigger. So this is what we know. So we are hoping, if this is the case, we really would like to find that this diverges, because if b sub n diverges, then a sub n will also diverge because this function is bigger. So that's what we're going for. So I'm going to be looking at the series n equals 1 to infinity of 1 over n plus 1. And this one, since it is easy to take the integral of this one, that's exactly what I'm going to be doing. So I'm going to be using the integral test on this one. And so I'll actually be finding the limit as w approaches infinity of 1 to w of 1 over n plus 1. And if you did a u substitution, we'll get u equals n plus 1. du equals 1. You will notice that this ends up being ln, so I will be having the ln of n plus 1 evaluated at w and 1. I'll get the natural log of w plus 1 minus the natural log of 2, and we'll be finding the limit of that as w approaches infinity. And if I plug in infinity, we will get an answer of infinity. So this function, this series, does diverge, and since our series in question is bigger than this series and this one diverges, then so does ours. So we are going to say, since a sub n is greater than or equal to b sub n, and b sub n and the series n equals 1 to infinity of b sub n diverges, then so does this one. So does ours. So that's how we will do that. Now, if this would have come out that it converges, I would have had to try something different. So I'd have had to try something maybe bigger than that and see how it works. Maybe I could have tried n squared, because I knew that that would be, this one would be bigger that time. So, and again, this would have been a lot easier using the nth term test, but I did want to show you the direct comparison test in that one. All right, example 2, does the series that I do not want again, we're just going to start with something a little bit different again. Let's put n equals 0 to infinity, and then we have 1 over the square root of n to the 5th plus 7. All right, and we would like to know that does it converge or diverge, and we would like to use the direct comparison test. So we're going to call this one a sub n, so a sub n equals that. So I would like my b sub n to be something hopefully a little bit simpler than this, and so to make it a little bit simpler, if I make it the square root of 9 to the 5th, notice that plus 7 isn't in there, and I've basically turned this into a p-series problem, which is really nice for me. So I just need to figure out which one's bigger. So we can start listing the terms of the sequence, but I notice if I have plus 7 down in the denominator, that this b sub n is going to be bigger, so a sub n is going to be smaller than b sub n. Since a sub n is smaller than b sub n, I'm really hoping that b sub n will converge, because if it does converge, then I have something to go on. If it doesn't, then I got to pick something else. All right, so we're going to be finding n equals 0 to infinity of 1 over the square root of n to the 5th. And I do notice this is a p-series, but I do need to rewrite it as 1 over n to the 5 halves. So now it's truly a p-series. So I will write it's a p-series. And in this case, p will equal 5 halves. And I do notice that now p is greater than 1. And if p is greater than 1, this series will converge. So I got lucky. So it does converge. So I can say, since a sub n is smaller than b sub n, and the 0 to infinity, the sum of the series of b sub n converges, then n equals 0 to infinity of a sub n also converges. All right, so really the trick on this one is going to be find that one to compare it to, and it will take lots of practice, and it will take lots of times where you don't get something that works and you have to try something else. So just hang in there as you're doing these problems.